All right, how's everybody doing today? This is Mr. Muscarella coming at you, and we're going to take a quick look at solving trig equations by taking square roots. Now, the first thing that I want to do before we get going into this, just kind of review taking square roots using algebra. So in the very first example, we would just divide both sides by 3, right? And you end up with x squared equals 1 over 3. Now, here's where you have to be careful. When you go to solve for x squared, don't forget to plus or minus around the square root. So plus or minus the square root of 1/3. And then, of course, you're going to need to rationalize that. So plus or minus 1 over square root of 3, because the square root of 1 is 1. And you guys should know or be pretty familiar with, you'd multiply that by square root of 3 over square root of 3. And you might be able to skip that step and go right here to plus or minus square root of 3 over 3. That's the idea behind solving equations by taking square roots. There's only one term that is squared, and everything else are just regular numbers. Now, if you think you got it, try the second example on your own, and then let's come back and see how you did. All right, so how'd you do on this one? Hopefully, you ended up with x equals plus or minus 2 square roots of 3 over 3. Now, the main thing when you're solving this or any type of math problem is, of course, be neat, be organized, and I always like to say keep your equal signs lined up so that way there's a flow to your mathematical thought process. All right, so those are just quick a couple of algebra examples, and let's go ahead and get into our first example. Now this is just going to be like the first warm-up problem. We're being asked to solve this equation from 0 to 2 pi, including 0, and we've got 3 tangent squared theta equals 1. So with this, what you'll do is you'll start by dividing both sides by 3. So you have tan squared theta equals 1/3. And then, just like we had x squared equals 1/3, now we just have a trig function instead of an x. So you're going to just say, you're going to square root both sides, so you're going to get tangent of theta is going to be plus or minus the square root of 1/3. And then we're going to go ahead and rationalize the other side. And we already did that, so you should know plus or minus the square root of 1/3 is going to end up being plus or minus square root of 3 over 3. So now I need to just look on the unit circle because I'm looking at 0 to 2 pi and see, like, where does that occur? And that, my friends, is over here at this value, boom, and then over here at this value for negative square root of 3 at 5 pi over 6. And then, of course, we're going to have 7 pi over 6 and again over here at 11 pi over 6. So we get 2 positive ones and 2 negative ones. And sometimes people like to kind of group them, you know, the 2 positive ones. So you might say theta equals, if I did the 2 positive ones, I'd have pi over 6. And then my other positive one would be square root of 3 over 3 is at 7 pi over 6. And then the 2 negative ones would be at negative root 3 over 3, or is going to occur at 5 pi over 6. And the other one occurs at 11 pi over 6. 11 pi's over 6. All right. And, I put 7 pi over 3. This would be 7 pi over 6. All right, so those would be the values where the tangent of theta has that. So these would be the solutions to this equation. Now to check this, we're going to go ahead and use Desmos to do that. And you could also use a graphing calculator. I'm not going to show you how to do this using Desmos. All right, now let's go ahead and get our screen set up in Desmos. So before we do that, the first thing that you want to do is take the 2 pieces of the equation and put them each in their own line. So on the left side, if we go back up to the top, we had 3 tan squared theta. So that is going to go in one line on Desmos, and then the right side is going to go on the other, y equals 1. Now for theta, just go ahead and use x. Now you have to be careful when you type in a tan squared, make sure you come back down, so you're going to have to move just like you would on a graphing calculator. Now the setup for your axes is shown right here. So go from negative pi over 2 to 2 pi and have that step interval just be pi over 2. And then the y-axis go from negative 3 to 3 with a step size of 1. So once you get your axis set up, then you'll be able to see what our solutions are. And we came up with, what did we have? We had pi over 6, 7 pi over 6, 5 pi over 6, and 11 pi over 6. So let's see what that looks like in Desmos. All right, so here's our graph, and we can see that the tan squared is a parabola one, a 3 tan squared, and then we have our other line, y equals 1. Now, if I look at right here and click on that, that's, ooh, look at that. Where they intersect, that's pi over 6. So that's one of my solutions. And then I have another intersection spot right over here, which is 5 pi over 6. And I have a third one at 7 pi over 6. Then I'm going to have to keep going because I want between 0 and 2 pi. So that would be my last one here is 11 pi over 6. That's pretty cool. Now, if we were to keep going after that, I mean, there's an infinite number of solutions, and we'll talk about that in another video. But I have 13 pi over 6 and so on and so forth. So there's going to be 1,000,001 solutions. However, I mean, there's going to be an infinite number of solutions, but we're only taking a look at the ones between 0 and 2 pi. So at 13 pi over 6, I don't have to worry about that. I'm done. So 11 pi over 6, 7 pi over 6, 5 pi's over 6, and then, of course, then we had our first pi over 6 right here. So those are the 4 solutions that we would get for this problem. All right, that's it for this example. Thank you guys for watching. Come on back and check out example number 2. Peace.